All right, continuing from the last video, we were putting together our table of inequalities, graphs, alternate graphs, and interval notation. We had gotten through most of two examples, and then the next two examples, we had gotten to the graphs. I'm just going to quickly redo those graphs. For x is less than or equal to 2, we're looking for numbers that are less than or equal to 2. Well, numbers that are less than 2 are to the left of 2 on the number line. So we need to shade everything to the left of 2 on the number line. And then in this situation, x is also allowed to be equal to 2. So to denote that, we put a closed circle on the 2. The last problem is very similar, except x is not allowed to be equal to 2. So we're still going to be shading to the left of 2, but instead of an open circle at 2, we're going to, instead of a closed circle at 2, we're going to put an open circle at 2. That communicates that 2 is not a solution. All right, let's move on to the alternate graphs. Remember, instead of open and closed circles, we use parentheses and brackets here. It's just another way of communicating it, another way of doing it. So in this problem here, x is less than or equal to 2. We're still going to shade the part to the left of 2. So we're still going to shade everything to the left of 2. But then at 2, instead of using a closed circle, we're going to use a bracket to represent that 2 is part of the solution. And then for the last one, again, still shading to the left of 2. But instead of an open circle, we're going to use a parenthesis to represent that that's not a solution. One thing that you've got to be careful with your brackets and parentheses is that they have to open in the direction of the shading. Here, the bracket and the parenthesis are opening to the left because that's where we're shading. And up here, they're opening to the right because that's the way we're shading. It's just the convention that somebody made up a long time ago. Now, we have our graphs for all four types of inequalities: greater than or equal to, greater than, less than or equal to, or less than. If it's greater than, we're shading to the right. If it's less than, we're shading to the left. If it's allowed to be equal to, we're using closed circles or brackets. And if it's not allowed to be equal, we use open circles and parentheses. That is an overview of how we do the graphs. We've got one more thing to do. We've got interval notation. This certainly might be something that you've never seen before. I imagine most of you at some point in your lives have seen the graphs, but interval notation is another way to represent the sets of solutions. Because in each of these, there's an infinite number of solutions in the shaded region. And so another way to represent those solutions is to look at the shaded region and to look at the endpoint where we've stopped shading. So let's look at the first example. X is greater than or equal to 2. Here, if you look at the shaded region, it goes all the way on the left to 2, and then on the right, it keeps going towards infinity. So we can actually write 2, infinity, meaning on the left side, we end our shaded region at 2, and on the right side, we go all the way to infinity. Now, there's something important that we have to look at here. If we look at the next example, we're also shading from 2 to infinity. So we would also have 2, infinity. We need a way to distinguish between these two because these are two different answers. And so far, we've got two of the same representations here. Well, to do that, the difference is really whether 2 is an answer or not. And we use the bracket on the 2 to represent when 2 is a solution, and a parenthesis on the 2 when 2 is not a solution. By default, we always use parentheses when we're dealing with infinity, because infinity can't be a solution. It's not a number, it's more an idea. So just the rule, it was with interval notation, we always use parentheses with infinity. Let's look at the interval notation for these last two examples. Here, the intervals end on the right-hand side at 2. So they go all the way up to 2 on the right. For the left quantity, we look how far do we go to the left, and we keep going forever and ever towards negative infinity. We don't say regular infinity here, we say negative infinity, because when we go infinitely far in the negative direction, that's negative infinity, not positive infinity. So both of these go as far as negative infinity on the left and 2 on the right. So both of them will have negative infinity comma 2. But the difference here is that in the first one, 2 is a solution. We represent that with a bracket. And in the second one, 2 is not a solution. We represent that with a parenthesis. And again, we use parentheses whenever there's an infinity. So here we have interval notation. This is just another way to express the solutions. This could be really useful when we're dealing with computers, because with a computer, there's no graphing symbol on the keyboard. We can't type a graph into the computer, but we can type brackets and parentheses. So this is just another way to communicate the same sort of thing. There are several examples below in the linked videos of inequalities where we do the graph and we do interval notation, so you can get practice with the interval notation. And there are even some examples of double inequalities that have more than one inequality symbol in them. So make sure to check those videos out. In the next class, we're going to look at how to solve more complicated inequalities, like the ones here, the inequalities that have a lot going on. And then after we solve them, we're still going to graph the solutions. So today we're looking at graphing, and in the next lesson, we look at solving.